several concepts that you need to be aware of, right, and be able to identify. Right? They apply to both addition and multiplication for the most case. The first one is commutative property. When you're dealing with commutative property, this general form is if you take the sum of two values and then you switch the order of them. Doesn't matter what order you add two quantities. Will you always get the same sum? A commutative property means it doesn't matter the order in which you add two quantities. And so this is the commutative property of addition. And does this work with multiplication? Is A times B equivalent to B times A? No matter what numbers you're using, yes. So it works for multiplication as well. And is it true that A minus B is equal to B minus A? No. Is it true that A divided by B is equal to B divided by A? No. And so the commutative property only works for addition and multiplication. Okay, the next property to be aware of is the associative property. The associative property states if you have the quantity of two things added together and you add it to a third, that is equivalent to grouping the final two concepts or the final two values and adding them to the first. This does work. This is called the associative property of addition. And then the associative property of multiplication, a similar concept. You can take the product of the last two, group it together, and then multiply by the first, and you'll always get the exact same product. And the place where this one winds up coming in handy, and these properties you usually will use without thinking about them. And if you had something like this, if you had 26 times 5 times 2, and can you do that in your head? What's the product? And you guys did that by reorganizing them, right? You take the 5 times 2, which is 10, a nice easy number to work with. 10 times 26 gives you 260. Okay, so that's the kind of the application of the associative property. And where you kind of combine both of them would be is if I gave you something kind of like this, 5 times 26 times 2. Okay. What you notice in the associative properties, did the order of the terms or product or the factors change? No. When you're looking to identify specific properties, now remember these are much like proofs. When you identify it, it's one step, so you can't combine the two steps. But what you can do mentally is combine them. So if I gave you this quantity to multiply, it's the same thing. Instead of trying to go from left to right, if you think about reordering these, which of these properties involves reordering? Commutative or associative? Commutative reorders. Okay. Associative just regroups. So if we were to reorder this using commutative property, so saying something like 26 times 5 times 2, so we applied the commutative property to these two, just switch the order of them. And now you can apply the associative property and multiply here, and then you get your product 260. Again, all of this takes place mentally. You don't necessarily think about it, but I wanted just to point that out. Okay. Two other properties that you need to be aware of, the distributive property. When you're looking at the distributive property, it's involves multiplying a factor times the sum of terms, and it comes up with distributing is what we call it, the A through. You'll multiply each of the terms in the sum by the term that's being multiplied out front. Again, everybody should be extremely familiar with that. And then the final one is the zero product rule, which will come into play a little bit later. And the zero product rule states that if you have some product set equal to 0, then you can solve this by setting either A equal to 0 or B equal to 0, and then again solving the equation. So zero product rule is just what you use to help solve equations. And once again, it should be something that you are familiar with. Okay, so if you look at sample problem number 6. And this is on page 5 of the pre-cal portion. Okay, I want you to see for A, B, C, and D if you can identify the properties that are illustrated in each of those. All right, so for the first one, which property is illustrated? You take this factor out front, distribute it to both terms on the inside, so that's distributive property. Good. What about the second one? Okay, again, when you look at this, even though there's 3 terms involved here, one set of terms is kind of grouped together and it stays grouped together. And then the order of these terms switches. So this is commutative property of which operation? Addition. Good. Okay, what about C? Again, commutative, we switch the order. The A and the B get switched. So that's an example of commutative property. This time of multiplication. And then final question. Here, the terms stay in the exact same order. 2x, then 2/3 y, then 3z. The only thing that changes is the grouping symbol, so that's an example of associative property, in this case of addition. Good. Okay. Really, other than using your calculator to calculate values, that's all this second section involves.